Hello students, in class 11 we have gone through the differential derivatives and limits and derivatives. Further, we will continue this chapter in class 12 and I have taken that initiative with the previous knowledge. What is differentiation? Basically, it is way to monitor the changes. What kind of, how we monitor change? I'm just reflecting the ab initio method. So I have taken y is equal to fx is there. So, and this is the explicit function earlier known to you. Now there is a small increment in x, so that will in y also. So this is fx plus del x that we can write down. And del y can be written down. This is f of x plus del x and minus y. This implies del y is equal to f of x plus del x minus fx. Now this implies del y by del x, we can write like this, is equal to f of x plus del x minus fx upon del x. That we can write down. Del x is very small amount, so we can del x tending to 0. This is del y by del x, and that is limit x del x tending to 0. This is f of x plus del x minus fx, and this is x plus del x minus x we can write down. So what we are seeing, this is basically this is dr by dx. What is dr by dx? This is the rate of change of y with respect to x. Limit del x tending to 0, f of x plus del x minus f of x upon x plus del x minus x. So this is basically rate of change of y with respect to x. Now I am taking a particular function of let you are having a function. This method is basically said to be a ab initio method or first principle. In class 11 we have gone through that, and now I am again repeating so that if people can recall the memory regarding the derivatives, and further we will proceed the chain rule and what are the different kinds of the differentiation in this class 12. So just I have taken a function just sin x, y is equal to sin x. We can write it like this: y is equal to del y, means there is a small increment x, and that is del x, so that is in y. So del y is equal to sin x plus del x minus of, so this is sin x plus del x minus y. So del y is equal to sin x plus del x minus of sin x, because y is the sin x. So del y is upon, now del y upon del x, dividing both sides by the del x. This is sin x plus del x minus sin x upon del x. And since del x is a very small amount, so we can put them down del x tending to 0, and this is del y by del x. This is this side also we will put del x tending to 0. So sin x plus del x minus sin x upon del x, and this is dr by dx, basically dr by dx, limit x del x tending to 0 dr dx, and this side will use the C and D formula, and this is 2 cos x plus del x by 2 into sin del x by 2 upon del x. Further, we write down dr by dx is equal to limit del x tending to 0 cos x plus del x by 2 and sin del x by 2 upon del x by 2. So we have segregated this like this, and since del x tending to 0, this amount will going to be 1, and this amount going to be cos x. So finally what we'll have, d of sin x, derivative of sin x is nothing but it will be cos x, as we are seeing in the method which we have used right now. Now I am putting all the results of related to the differentiation first, so that people can recall it. Here is this Differentiation of constant will nothing because there is no change and constant will be 0. Second, differentiation of sin x, this is dx as it is cos x. Third, differentiation of cos x, it will be dx is equal to minus sin x. Fourth, differentiation of tan x, it will be sec square x. 5. Differentiation of ex will be ex. 6. Differentiation of x to the power n dx, it is nx n minus 1. 7th, differentiation of log x upon dx is equal to 1 by x. 8th, differentiation of sec x dx, this is sec x into tan x. 9. Differentiation of cot x, this is minus of cosec square x. 10. Differentiation of cosec x, this is minus of cosec x into cot x. 11. So number 11 is d of ax dx is ax log a. 12th will go like that. This is tan inverse of x is dx is equal to 1 upon 1 plus x square. 13. This is d of sin inverse x is equal to dx is equal to 1 upon root under 1 minus x square, and so many other results we can configure it and we can see that. Now I am writing the basic rules for differentiation. As earlier we have already gone through these things. Again I am repeating so that people can recall. This is differentiation of fx plus gx, two functions together. First rule is that, or plus minus dx. We can separate it and differentiate both the functions. This is dx and dx plus minus d of gx upon dx first. Second, we will go with the differentiation of. So second is d of fx into gx, dx is equal to, it is a product rule. Basically, we will take fx outside and we will go with differentiation of gx and dx plus we'll take gx outside and we'll differentiate the fx. This is the rule that is to the product rule. And third is d of f of x upon gx. This is the division rule, you can say like this. And dx is equal to, so we'll take gx outside, we'll differentiate the fx and dx minus, we'll take fx outside, we'll differentiate of gx and dx up whole upon, we will gx whole square. So this is the way we can go with the three rules. One more is that if constant is with the fx, non-zero constant k is there, dx, we will take constant outside and we will go for the differentiation for function. This is basically the rules. Basic rules we have already gone through in the 11th class. Again I have initiated that so that people can recall it and you can just correlate when we will start the chain rule from syllabus for the 12th class for the limit and derivative. So derivatives starts in 11th class with the chain rule. So we will start that. And further, this is the chain rule which I am going to start now. The first thing which you have to pick up for the class 12. Suppose y is equal to sine of x square you are having function and you have to differentiate it. There is two ways to go for. One is the substitution. Y is equal to, we can write down sine u, where u we have taken x square. And we can differentiate dy by du for this one. This is d of sine u, and as we have no du with respect to u, this will be cos u. When we will go with the du by dx, because this is 2x. So for this is du by dx is equal to 2x, and then we'll club both and that. So what is the du by dx? We can write like this: dy by du into du by dx, and that will give you the cos u into 2x, and we'll put the value of u, this is a cos x square into 2x. So basically differentiation for Sin x square will be like that. But this process is the substitution method. There is another method, second. This is the first one. First way to go with the chain rule. Second is we can go with the continuous process. Sin x square. How we can go for? Differentiating both sides with respect to x, and we can write down dy dx is equal to d of sine of x square. So we'll use the composition function till it is not going to be differentiate all the composite functions with that. So this is, we have taken the standard form x square is x square here. Again we'll go with the x square with the dx. So it is continuous process cos x square into 2x. Again I am repeating. If it is dy by y is equal to sin x square, dy by dx will be sin x square upon dx. You have to take this function here and then further you have to go for. If anything more, we'll further go for. So all the composite function will differentiate one by one and we can go by the process, and that is the also a second method of the chain rule. So this is the beginning, and there are so many other function and so many other things. Time is not just allowing me to move further. I'm saying here to you, just go through the contents, whatever I have given to you for today, and just wait. Further, we'll talk regarding the few more inputs with the chain rule, and it will be work out. Okay.